Good morning, students.
Good morning, sir.
Standing before you is Mr. Uchebo Raymond, the inventor of the Geotrigmetric set, both teachers and student sets. We are here to use this Geotrigmetric effectively to teach one of the chapters of the book that is handled on Geotrigmetric set. This class, we are going to deal on quadrilaterals. Quadrilaterals. Let us refresh our memory by mentioning what they are. So, who can tell me it's an example of quadrilateral? Yes? Kite. Square. Trapezium.
Kite. Square.
Trapezium.
Rectangle.
Parallelogram. Very good. Now, bring out your strange geometric set. Now, the first quadrilateral I mentioned was square. So let us use geometric set to check properties of square and see that those things you've been cramming, you could have seen them practically without cracking your brain to cram them. Just study, look the ruler on your board and study the board. What I need is only the board, like this. Have you done that?
Yes.
Okay. Now, study the board. What do you see? What can you say about the size of the board before you? What can you say about the size? If you know, if you keep a raise up your hand. Yeah.
The sides are equal to each other.
Properties of square. One of the properties of square is that all the sides are equal. When you look at your board, you see that this side is equal to this side, is equal to this side, is equal to this side. So you have achieved that property by seeing it, by observation. You have observed that all the sides are equal. This one is parallel to this. Okay, let me see the ones that are parallel in your one. Parallel to with what? This one. Very good. Push other one parallel. Parallel with which one? Very good. Show me. Very good. Very good. This one parallel to this. This one parallel to this. We have done one that all the sides are equal. Opposite sides are parallel. What other property of a square?
It has 4 lines of symmetry.
We are going to see the lines of symmetry. This is a square. If you divide this into 2 equal parts, this is one line of symmetry. You should do it in your own. Let me see. No, your own is not the turn. Put your own at 2.5. Because it is 5 cm. The whole is 5 cm, so divide it into 2 equal parts. Let's see the line of symmetry. Here is 10 and 10. We are considering this square. This is the second line of symmetry. We have done the other one this way. This is the second line of symmetry. You can place your ruler and see the line of symmetry. Before we continue, I want someone to tell me the meaning of lines of symmetry so that I will make sure that what we are doing, that you know what we are doing. So what do you have in mind to achieve in line of symmetry? Yes?
What we have in mind is that we want to know how many shapes, how many sides, when we divide a shape, how many equal parts that we can get.
Very good. It is a line that divides a shape or object into two identical parts. No one will be more than the other. Now, this line that divides me exactly into 2, this side and this side, not be identically. That's equal. None one will be greater than the other. That line is line of symmetry. So that's what we are achieving. So we have done 2. Let's also get the third line of symmetry. the diagonal that if you put it at 45 degrees, you can see here is 0, 10, 20, 30, 40, 45 degrees. You put this to pass through 45 degrees. So when you put it, you use ruler 6. Don't use ruler 7. Anytime you are putting one ruler, use ruler 6. The one by the right hand side. One has depression under. The one that has depression under is ruler 6. The one that has depression on top is ruler 7. Anytime you want to use the ruler, you must use it this way. This way. Do not use it this way. You must use it this way. And when I ask you to join it together, you join it this way. Here is 0 degrees. Here is 10, 20, 30, 40, 45 degrees is this. And it is diagonal of this square. It divides this square into 2 equal halves. Here is 45 degrees, here is 45 degrees, here is 45 degrees, here is 45 degrees. From this tip to here. That's from here to here, 45 degrees. 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 So here is 45, here is 45, here is 45, here is 45. In other words, it is a line of symmetry. Dividing this square, this line divides this square into 2 equal parts. It is a line of symmetry. Huh? Then the fourth line of symmetry. That's the one you will use ruler 7. You use ruler 7. That's why you use ruler 7. Can you see? So you can pin it like this one as a hook. You can pin it. You must know the one that is 6 and 7. Let me use yours. Bring it in. Okay. The last but not the least is the one you said now, which is that diagonal bisect each other. This diagonals, this one, that very property is what I want you to use this material to check. We are going to perform it practically now. What we do is to pin ruler 6. Then pin ruler 7 at W. Pin ruler 7 at W, ruler 6 at N. Diagonal here, this one form diagonal here. Then you see that they will meet each other at where? Where?
What part?
Not the angle, but the diagonal bisect each other. 3 points. What a problem did you envisage? You encountered a problem trying to form the diagonals. I want to tell me the problem you encountered. Yes, it was not flat because of the thickness of the ruler. But you were able to pass it on top to estimate the diagonal. When you estimate the diagonal, this other one, they will pass each other at 3.5, 3.5. That very theorem can be demonstrated here. But it may be difficult to be demonstrated here because of the thickness of the ruler. Look at it, this ruler 6, put it here. This ruler 7, because of the thickness, it cannot be flat. But you can estimate you can estimate the diagonal, and here they meet at 14 cm, 14 cm. In this one, they bisect each other at 14. Your own bisect each other at 3.5. In summary, can someone stand up and tell us all the properties of a square? Just one person. I don't want chorus. One person. Stand up, tell us in summary properties of square before we can go over to properties of rectangle. Yes?
All the sides are equal.
Good. All the sides are equal.
They have 4 lines of symmetry.
4 lines of symmetry. 2 diagonals bisect each other, which we have demonstrated. Which other property that should not mention?
All the 4 angles are right angles.
All the angles are right angles. Let me summarize it. Let me help her. She has tried. The first property, all the sides are equal. All the angles are equal. Equal first. All the angles are equal. All the angles are equal and right angle. There are 2 things now. All the angles are equal and then right angle. Opposite sides are parallel. This one parallel to this, other one parallel to the other one. The diagonals bisect each other. Then 4 lines of symmetry. Am I forgetting anyone? No. Thank you very much. We go over to rectangle. Okay. Let us check properties of rectangle. Properties of rectangle, they are similar to properties of square. Has 4 lines of symmetry. A rectangle has how many lines of symmetry?
2 lines.
2 lines of symmetry. Because the diagonals do not bisect each other. These are other identical square. 2 of them now form a rectangle, as it is in your own. When I say anything here, you look at your own geometry set. If you put this here, you see this angle is bigger than this one.
Yes.
So this is not lack of symmetry. In the same way, this angle is bigger than this one. So they are not equal. Therefore, this is not a line of symmetry. I don't know whether the diagonals bisect each other. Even though there is no line of symmetry, whether they bisect each other. So what you do is to pin ruler 7 here and put this way. Pin the other one here and estimate the diagonal. They bisect each other. They bisect each other. The lines of symmetry. The diagonals bisect each other. Put it at like 6 at a 30 degree. Then what is the shape? Form. Degrees. I want it to be uniform. Put it at 30 degrees. 10, 20, 30 degrees. Correct. The property that only one pair of opposite sides are parallel. That's this and this, only one pair. Or there is no other property. Don't this in a trapezium. That's why they different from others. Parallelogram. Parallelogram. 6 here. Put ruler 7 to form diagonal. Put ruler 6 to form the diagonal of this square. Put ruler 7 to form the diagonal of this square. Now, if you have formed a parallelogram, opposite angles are equal. Here is 45. Here is 45. Here is 135. Here is 135. How? This is 45 degrees, as you can see for the protractor, is it not? If this 45 degrees, this is equally 45 because it is a angle formed by diagonal in a square. Diagonal of a square by divide the angle into two equal parts. So if this is 45 degrees, this is 45 degrees. Both of diagonal of a square. Is it not? In the same way, here is 45. Here is 45. Here is already 90. So 45, 45, opposite angles are equal. 90, 45, 135. 135 degrees. 135 degrees. So here is 135. Here is 135. That is 45 plus 90. 45 plus 90. 135, 135. 45, 45. So it has formed a parallel. Did you mention rhombus? Yes. Very good. Rhombus. This is upper part of the rhombus. Yes. This one, upper part. If you measure from here to here, say NS equal to SK. If you produce this line, then you join here, join here. That's how you can form a rhombus. You get this one from the Geotrigmetric and draw the other one. How will you do it? You measure from here to here, equal to here. Then you join here, it is a rhombus. Because it is a square that is distorted. A square you push, when you push a square, the square will, the angle will be deformed and it forms a rhombus. The sides are equal, but it's just like a parallelogram. Except that all the angles are equal. Sorry, opposite angles are equal. It's just like a parallelogram, except that all the sides of a rhombus are equal. You can call it special parallelogram. Is it not? A special parallelogram in which the sides are equal. Parallelogram is the opposite sides are equal. But in rhombus, all the sides are equal. By the time you get the handbook, you will see everything in details. That it is a special parallelogram. It is a square that is distorted. When you get a square shape, and you push it by the side, it goes this way. It is no more a square, but a rhombus. If you call it a parallelogram, it is because you don't know that the special name is rhombus. Rhombus is special parallelogram in which all the sides are equal, like in this one. So when you push it back to form 90 degrees, it becomes a square. But when you push it to distort the angle, it forms a rhombus. The last thing we shall do here is kite. What is the difference between rhombus and the kite? Yes? Only
one pair of sides.
very good. Very good. Equal. But in a kite, only one pair adjacent. One pair of adjacent. You put one pair of adjacent. This is upper part of rhombus. That here is 23. The one we formed before. Instead of drawing 20 cm to match up here, you draw 40 cm or 30 cm down. That is from here. This your SK will become more than this. Once it is more than this, if you join, this side and this side will be equal, but it will be more than these two sides. And that is a kite. It is no more rhombus, but it is a kite. Mathematics is interesting. It is sweet. The way we handle it is what is making children to run away. As inspector of education, God knows and my ministry knows I'm doing this as a sort of evangelism. Do you understand me? If you have any question, you can ask. Yes.
Master, how do you say that trapezium? How do they bisect each other?
Trapezium. No, they don't have. They don't do bisect each other in a trapezium. It's only in a square and rectangle that diagonal bisect each other. Trapezium, no. Other question?
How do you find the lines of symmetry?
Line of symmetry in trapezium. No, it is only in one case. If it is isosceles trapezium. It is only in this case. This is called isosceles trapezium. Isosceles trapezium. It is only on this condition that this is line of symmetry. Because this one is growing bigger, this one is growing bigger. And this one is coming up, this one is coming up. So this is considered as only in this case that you can have line of symmetry in trapezium. Others don't talk of trapezium here. When the line of symmetry, when the trapezium is an isosceles trapezium, it's not any other trapezium, no. I feel like stopping here for now. This chapter, I have rushed this chapter now. I'm happy you can now, don't wait for anybody. You can now on your own bring this your geometry set. This is the small leaflet that will guide you for now. Until the book comes out, the handbook with exercises, the handbook that has problems, exercises you will solve after each topic. Until it comes out, you can use this to be operating the gadget. You understand? So you can manage with this. I don't want to go beyond quadrilaterals here. My email address is here. If you open the box, you see my email address. You can send me email and ask me questions. I will answer you online. I am online. You can ask me questions by sending me email. Just send me email. Ask me questions on this. I will answer. I teach a lot of people online. People ask me questions and I reply. The speaker from Lagos State. But now that I've interacted with you, I hope to have mails. But I can't do without searching my mail every day to answer questions on this. Thank you very much.